All right, thank you, Dr. Bob, for the introduction. The last time we were all together, I talked about some of the genetic data from these same isolates. So since then, I've had a chance to phenotype some of this. So let's get into that. Use the keys. That's what I'm doing. No.
Okay, you advance with this. Okay,
Oh, okay.
yeah.
All right, thank you. So this right here is just to show that basically section nigri is all dark spored Aspergilli. So they're not all going to look exactly the same. All right, just a little bit about the economic background. In Georgia, the farm gate value is roughly $13 billion. Peanuts accounts for 663 million from that. And actually seedling disease loss is $3.2 million. And here I just wanted to show exactly what ground rot looks like. As you can see here, there's a large portion that actually comes in on seed, as you can see via the cotyledons there. So seed treatment, Aspergillus section nigri been a problem to seed and seedlings. So we really started off with Viavax PC, which has carboxin, PCMB, and Captan. And then we moved on to Dynasty PD, which is oxystrobin, fludeoxonil, and mefenoxam. So right here, I wanted to show that Abound, which is our azoxystrobin, has been used in the past in furrow. In the back of the left picture there, you can see that that once upon a time it worked. And here lately, no longer is it recommended for in furrow because as you can see in the forefront of that picture, what's going on. And we do put it in right at planting. So we moved on to a lot of the production has used on Rancona as a seed treatment, as carboxin, metalaxone, iconazole. This started because the transition, I say, started because of suspected azoxystrobin resistance. So Abound or azoxystrobin, labeled for use as a foliar spray for leaf spot, stem rot, and rhizoctonia limb rot in 1998. It was labeled for use as in furrow spray on peanut in 2000. Dynasty PD was labeled for seed treatment on peanut in 2006. Now it actually took over the market pretty quickly. Dynasty PD was a predominant seed treatment in Georgia by 2010. It was really starting before that, but it pretty much had the bulk of the market in 2010. All right, here I'm just showing the model of the electron transport chain. So where you see the little red circle, that's the quinone outside location where the QoIs block the transfer electrons, thus halting production of energy. So crown rot problems using Dynasty PD as a seed treatment or Abound azoxystrobin in furrow. We're starting to show some resistance to Anheuser, so that give us that suspected of what's going on. So the last time we were together, like I said, I was talking about some of the genetic data. So out of I've got 238 isolates. 5% of them had the G143A mutation. Approximately 70% had the F129L or the phenylalanine to leucine. I didn't find any with the G137R mutation, and that only left about 25% of my isolates that were wild type. So that told us that phenotyping for sensitivity to azoxystrobin was needed. And I should point out that in most pathosystems, the G143A is like a switch. It either works or it doesn't, whereas the F129L tends to be a gradient, and moderate levels of resistance. Okay, so I just wanted to show here the point mutation right there in the center. You can see where the TTC is converted to TTA. And that shows the where the phenylalanine here changes to. Let's see. And I got my reference genome from the Aspergillus project. So the objective is to determine the EC values for 238 isolates of the Aspergillus sectionigri and compare to the cytochrome BC1 mutations. So what I'm presenting here today is 20 random selected isolates, and the rest of it will be forthcoming. So I took 20 isolates from random from seed, peanut plants, and the USDA collection. The concentrations I used was 0.001, 0.01, 0.03, 0.1, 0.3, 1, 3, 10, and 30 micrograms per mil. Give me a total of 10 concentrations, 3 reps, and 2 experiments. So I used acidified potato dextrose agar, APDA. I don't have it in here, but I also use sham in my experiments to block the alternative pathway. Alternative oxidase pathway. I standardized it to 1 × 10⁴ spores per plate. My tween 20 water concentration of 0.05% tween. I counted 100 random spores per plate, give me a percentage of germinated spores. And once I got done with that, I ran the probit model in SAS 9.4, and I just used an arbitrary threshold of greater than 0.1 EC50 value to be considered resistant. In the literature, I saw it anywhere from 0.01 to 1. It just depends in your pathosystem what you want to choose. So my hypothesis, moderate EC50 values will correlate with isolates that have the F129L cytochrome B mutation, while low EC50 values will correlate with the wild type isolates. Now in this subset, none of them had the G143A mutation. So right here just shows on a sensitive isolate what we see. As you can see, it's pretty much full growth in the control. Still pretty much the same at 0.001 micrograms per mil. And then you start seeing a lot less of the germination here, and especially here, and then pretty much no germination from there on down. Now, here we see a isolate that's completely resistant. And the growth is not as heavy once you get down here to 30 micrograms per mil, but the germination is there nonetheless. And with azoxystrobin and QoIs, spore germination is how it works. So, this is again completely resistant. Okay, so here are my results. The blue line signifies the resistance threshold. And as you can see here, the Georgia's seed is on both sides of the threshold, USDA isolates on both sides of the threshold. And then right down there at the bottom, you can see we got Georgia plant, USD isolates, old isolates, 2 of them. I got 3 here that are greater than 30. Now that becomes significant when you look at mutations here. So line 4 and line 19 are wild type isolates, and one is completely susceptible where the other one is completely resistant. And you see all of these with the F129L mutation. This was not what I expected. So you got some F129L that greater than 30 micrograms per mil. So we found this very interesting. So 10 of the 18 isolates with the F129L mutation had EC50 values above the sensitivity threshold. However, among these isolates, there was a wide range of EC50 values. And that forces us to reject the null hypothesis. These results confirm resistance to azoxystrobin in Georgia peanut fields and seed. And it should be noted, one isolate with none of the typical substitutions had a high EC50 value. This isolate was found in one of the research plots in Tifton, Georgia. And so when I found this, I didn't believe it. So I went back and resequenced it. Yeah, came up with the same result. So I'm not really sure what's going on in this particular isolate, and I'm interested to see how many more of these I find. So conclusions. Based on this preliminary sample, recent problems with crown rot correspond with fungicide plate assays, but frequencies of sequences in cytochrome BC1 gene associated with reduced sensitivity to QoI fungicides is not clear cut. Confirmation of azoxystrobin resistance helps explain recent results with Rancona versus the Dynasty PD for seedling disease control in peanut. It also explains why Abound is no longer effective in furrow. And isolate G101-1R does not have any typical mutations associated with reduced sensitivity, but has an EC50 of greater than 30 micrograms per mil. So future work. I'm in the process of expanding this EC50 work to all 238 isolates that I have, which is a ton of work. That equates to about 16,000 plates that I have to get spores in. The USDA is actually expanding the EC50 work to look at DMIs and HDI as well. So a lot of acknowledgements here. My co-advisors, Dr. Colbreth, Dr. Renee Arias, Dr. Katie Stevenson, Kim Brenneman, Maren Brewer, Dr. Bob Kemmerite, and then our tech, Mike Heath, and all of the other people that provided help, Damien, Ron, Tripp, and Nick. And also thanks to the Georgia Peanut Commission and National Peanut Board. With that, I'd be happy to take any questions.
Question for Brian. Question. Brian, I got a question. Since it's soil-borne pathogen, and it seems that it went from almost overnight. So across the production area, you went from having things were going well to things were not going well. How do you explain, or can you explain that observation? Is that observation even accurate in terms of very quick appearance of apparent resistance for soil-borne pathogen?
Okay, so I'm going to summarize Dr. Kimmerite's question. So the apparent sudden shift, what is causing it? I have a hypothesis. I don't have any data to support it. So we use QoIs for seed treatment, leaf spot, southern stem rot. It's used for a lot of things. And since Aspergillus is ubiquitous, it's in the soil, some of that spray is going to get to the soil. I suspect we have overexposure, non-target, effect there. Can I prove it? No. But that's what I really think is going on. That would be a great project for somebody to take on once I'm gone. That's truly what I think.
Any other question? Thank you, Brian.
All right, thank you.